Okay, our next lesson is assignment 24, 6.2. I'm going to split this up into 2 days. So originally 6.2 is to evaluate and to graph polynomial functions. Today our lesson is just going to be to evaluate polynomial functions. Okay, so your essential question is, what is a polynomial and how can you use synthetic substitution? So this is new to you. Synthetic substitution. Okay, you've never seen this before. And we're going to use it to evaluate polynomial functions. Okay? All right, so let's talk about what a polynomial function is. All right, so I'm going to write out an extremely crazy thing right now. F of x, which is a function, right? That's the output of a function, equals, okay, so we're going to have a sub n x to the n power plus a sub n minus 1 times x to the n minus 1 plus, and I'm going to put dot, dot, dot because these can go as long as we need them to, plus a sub 1, sorry, let's do plus a sub 1 x to the first power plus a sub 0, x to the 0 power. Okay, so a polynomial, for example, let's just give you a small example here. So maybe I had, for example, 10x to the 6th plus, I don't know, 15x to the 5th plus 7x to the 4th minus, let's do a minus in there. I'm making this up as I go along. 4x to the 3rd minus 2x squared plus 5x plus 7. Okay, so there's an example of a polynomial. So, oh, I'm sorry. Let's erase this. If we're going to do a polynomial function, then we need to actually put some kind of output in front. So how about f of x equals? Whereas originally all I had was an expression. So for a function, it's got to be an equal sign, right? Okay, so this is like your basic definition of any polynomial function. And this is just saying that, I have some coefficient on my leading term. So my leading term is always going to have the highest power. Okay, so like here, x to the 6th was my highest power, and the coefficient to x to the 6th would be 10. Right, so if this is x to the n, well, my polynomial goes x to the 6th. And then the coefficient, or a sub n, that goes with this first term is going to be known as the coefficient of x to the 6th, or the leading term. And then my powers decrease, right? So here my x has 1 less power than it originally had. Just like here, it has x to the 5th. And the coefficient that goes with x to the 5th here is the number before it, or a sub n minus 1. So on and so forth until we get down to where we don't even have any more x values, right? X to the 0 power, well, that means that that's just 1, right? Because anything to the 0 power is 1. So that just means I'm just left with whatever the coefficient of x to the 0 power was, which happens to be 7. Okay, and then the number before that would have to be x to the first power with its coefficient, and so on. So a polynomial function is basically made up of several terms, all of them being, added or subtracted together. Okay, so some important information about polynomial functions. I'll put those with little asterisks. Your exponents are whole numbers. You have no variables in the denominator. If there's a variable in the denominator, it's going to be called a rational function. Okay, rational like ratio, fraction. Okay, so anytime you have a variable in the denominator, you're not dealing with a polynomial function. You're dealing with a rational function. And we're not dealing with rational functions right now. So you don't need to worry about that. Okay, so if you see a variable in the denominator, just know that that's not something we're on yet, but we will get there. You will have no variables in the exponent. Because eventually we'll get to exponential functions, power functions, and those will have your variables in the exponent. Okay, and then all of your coefficients are real. So no imaginary or complex coefficients are happening here. Okay, so going back up to what we see here, just as a little key for you to have, a sub n is always going to be your leading coefficient. So in our example here, my leading term, the thing with the highest power, the coefficient of that is 10. N is always going to be your degree. And a sub 0 is going to be your constant, meaning there's no variable there. Okay, just like our last term here, a sub 0 was our constant because 7 has no x value with it. Okay, a couple more important things. Now, standard form. I know that we've said standard form for every different type of function that we've been dealing with. And the important thing when dealing with polynomials, you have no idea what the highest power is going to be. But it's important that you put all of your terms in descending order of the powers. Okay, so all terms in descending order. Descending has an S in it. Descending order of powers. So just like I wrote my original one up here in descending order of powers, right? X to the 6th, then x to the 5th, then x to the 4th, then x to the 3rd, and so on. And hopefully by now you know what a term is, but in case if you don't, I'll go ahead and define that for you. A term is going to be the product of numbers and variables. Okay, so for example, let me just give you, how about 3x cubed plus 7x squared minus 2x minus 5. All right, so my product of numbers and variables happens here 4 times, right? This first term, 3x cubed, another one, 7x squared, another one, negative 2x, and another one, negative 5. Okay, so I have 4 terms. And those terms are, here's one of them. Here's another one, and keep that sign with them. Okay, another one here, another one here. 4 different terms. All right, types of polynomials. I'm just going to go over a few of them with you. And most of them should already be familiar to you. So you're going to have the degree as one of the columns that we'll talk about. What type is it? So what's the name? What do we name that? And maybe what's an example of it? All right, so first one, a degree of 1. Well, if you have a degree of 1, that means it's x to the first power. That type is linear. An example of that would be maybe y equals x. So that's a line that goes through the origin. Another degree would be degree 2. If you have x squared, what type of polynomial is that? Well, that is a quadratic. And so I'll use the example y equals x squared, which we just got finished studying. And that becomes a parabola when you graph it. Okay, so far nothing too new here. Actually, nothing new. All right, let's get into something a little bit more new. I'm going to skip a little space here. What if I have degree 3? Well, degree 3, so something with 3 dimensions is a cube, right? So that's going to be cubic. And an example of that might be y equals x cubed. And you're not familiar with this graph just yet, but you will become more familiar with it. So your cubic function looks something like this, where it comes, it kind of flattens out at the origin and then heads back up. It goes from being concave down to concave up. So it's got a point of inflection right there at the origin. All right, and then the last degree I'm going to talk about today is the 4th degree, and we call that a quartic. Think of like quartiles, okay, or quarters. All right, so this one, the one I'm going to show you right now is just y equals x to the 4th power. And it looks a lot like a quadratic. Now, this won't always be the case, but for y equals x to the 4th power, it looks like this, actually, when you graph it. Okay? And we'll talk more about x cubed and x to the 4th. And we'll add more to these, and so you'll get to see a lot more about their characteristics and their properties. Okay, but those are your basic polynomials. You've already learned about linear and quadratic, and we're going to learn a lot more about cubic and quartic, and even more than that. Okay, so let's do some examples. So example 1 is the function a polynomial? Okay, if so, write in standard form then state the degree, the type, and the leading coefficient. All right, so the first one that we'll do together, we'll call that A. You're going to have f of x equals 2x squared minus x to the negative 2. Or in other words, right, we don't really like to work with negative exponents. So this could be thought of as f of x equals 2x squared minus, and I'll just take the reciprocal of this, so it would be 1 over x squared. Or the whole thing, 1 over x, the entire thing squared. Either way. All right, so is this a polynomial function? Well, let's go back to see what makes a polynomial function. Okay, so all of your exponents have to be whole numbers. So is that true? My exponents look like they're whole numbers. Okay. No variables can be in the denominator. Okay, so that also means that I can't have any negative exponents. Okay, so let's look at this. Here I had a negative exponent on my x, right, which put my x in the denominator. So that tells me that this is not a polynomial function. So I'm going to say no, and I'm going to give a reason here because it will be good for you guys to know why we said no. So I'm just going to say that there's a variable in the denominator. All right, moving on. Let's do another one. So how about we do f of x equals negative 0.8 x cubed plus x to the fourth minus 5. Okay, so again, I'm looking at this and I'm saying to myself, let me check and see if it's a polynomial. Are my exponents whole numbers? Do I have any variables in the denominator? Let's see. Exponents all appear to be whole numbers. None of them are negative, so they won't be putting my variables into the denominator. Let's see what other things we need to look for. We can't have any variables in my exponent, and all my coefficients need to be real. So let's see if I have any variables as exponents. My exponents are whole numbers, so that's not a problem. And my coefficients, in fact, are real. This is a negative 0.8, that's a real number. This is a 1, that's a real number. And then my constant. So yeah, this is a polynomial. So we'll say yes. Okay, now let's go through and give the degree. Let's make sure that it's in standard form. Let's make sure that we can tell what type it is. So I think the first thing I should do is put this in standard form. So really, I should bring my leading degree out in front. So the term with the highest degree comes first. So it's x to the fourth. The next one's going to be x cubed, so that's minus a 0.8 x cubed, and then minus 5. So this is in standard form. Okay, my degree is going to be 4, which makes this a quartic, right? And the last thing I need to talk about is what is my leading coefficient. So my leading coefficient, I'll just write LC for that. Well, the coefficient of this first term with the highest degree is 1. All right, let's do another one of those. So how about f of x equals 3x plus pi x squared. Oops, sorry about that. All right, so going through the list. So are all of my exponents of any of my variables, are those all positive numbers and whole numbers? They are. Okay, my coefficients are all real numbers, right? This is pi. It might be irrational, but it's still real. It's not an imaginary number. And I don't have any variables in my exponents. So it looks to me like this is a polynomial. So now I need to make sure that it's in standard form. Okay, so standard form would put the highest power first. Okay, and the highest power of x here happens to be 2. So I'm going to rewrite this in standard form. Pi x squared plus 3x. Okay, so my degree is 2, right? It goes to the second degree. My type, well, since it's to the second power, that makes it quadratic. And then my leading coefficient, that is the coefficient of the leading term. The leading term has the highest power, so my coefficient here is pi. Okay, moving on. Let's get to some great stuff here. So, example 2. You are going to use direct substitution to evaluate all right, so you've got a function f of x equals x cubed plus 3x squared plus 6x minus 11, and you know that x equals negative 5. So just like you've been doing for many years now, To evaluate this, you're going to directly substitute in -5 anywhere that you see an x. All right, so I will call this f of -5. And anywhere that I see an x, not only am I going to substitute it in, but in order to make sure that I treat the negative properly, I'm going to substitute it in using parentheses. So I put -5 cubed plus 3 times -5 squared plus 6 times -5 minus 11. Okay, so now I start to evaluate this. So -5 cubed, well, that's -5 times -5 times -5. So that's going to be -125. Plus 3 times, now -5 squared is going to be a positive 25. Okay, and then this becomes a -30 and a -11. Simplifying a little bit more. Let's see, I've got -125. And then that's going to be 75. So -125 and a positive 75 minus 30 minus 11. So -125 plus 75 minus 30 minus 11, that's going to end up giving us -91. Okay, great. That was nice and easy. Or was it? Can I give you a better example of doing this? Or can I give you an easier way of doing this? I can. Even though you're saying to yourself, well, that is super simple. It is, but it gets even easier. All right, so another way of doing this is to use a thing called synthetic substitution. Okay, so example 3, we're going to do the same exact problem, but we're going to use synthetic substitution. So use synthetic substitution to evaluate. All right, so there's a couple of important things whenever you're doing synthetic substitution. And I would highlight this. Okay, so I'm going to put those things in little asterisks, okay? First thing, it needs to be in standard form. And after it's in standard form, you have to put in a 0 for any missing terms. So insert 0 for any missing terms. Okay, so I'm going to do 2 examples with this. The first one's going to be just like the above example. Okay, so I'm basically using this right here. The exact one we just did, and I'm going to show you how easy this way is. Okay, so synthetic substitution involves taking this number, this x, putting it outside, and then doing like an upside down division bar, or upside down division sign. And then you take the coefficients of every term. So first term, my coefficient is 1. Second term, it's 3. Third term, it's 6. Last term, it's -11. Notice how I wasn't missing any terms. It went from 3, 2, 1, 0. Right, my powers. Okay, so I wasn't missing any terms, so I didn't have to worry about filling in any zeros. And it was already in standard form. So these didn't really need to be applied, but in another example, we'll make sure that I have to apply them. Okay, so synthetic substitution, here it goes. And I'm going to get out exactly what I got out in this original example that I did, where I just direct substituted. Okay, synthetic substitution, you bring down the first number. Then you multiply. Then you add. So that gives me -2. Then you multiply, that gives me 10. You add, that gives me 16. Multiply, that's going to give me -80. Add, that gives me -91. I'm done. Right? So you can directly substitute things in, or you can use synthetic substitution. And whatever you get here, that is the same exact number if you had directly substituted it in. Now, why do we do it this way? A lot of times it's going to be easier to use synthetic substitution because sometimes your numbers here will be so big that having to evaluate them could be challenging. Okay, but there's going to be other times where synthetic substitution won't be your best option. Okay, and this one, and I would say here for this example, you could go either way on this because they both worked out pretty equally easy. I'd say this one's a little bit easier, right? I didn't have to do quite as much arithmetic as I had to do up here. Okay, let's do another one. So this time we have the function f of x equals x squared minus x to the fifth plus 1, and our x will equal -1. Okay, so this one is not in standard form. So the first thing I'm going to do is I'm going to write it in standard form. So that's negative x to the fifth comes first, plus x squared, plus 1. Now notice I am missing some terms, right? I don't have an x to the fourth, I don't have an x to the third, and I don't have an x. So everywhere where I'm missing a term, I'm going to substitute in a 0. Okay? So the number that I want to substitute in goes outside. Then I do like an upside down division sign. Then I line up all the coefficients. Okay, so x to the fifth has a coefficient of -1. There is no x to the fourth, so I put a 0. There's no x cubed, so I put a 0. There is an x squared, and that coefficient is also 1. There is no x term, so I need to put a 0 there. They're kind of like placeholders. And then my last term is 1. That's my constant term. Okay, bring down the first number. Multiply. Then add. Then multiply. Add. Multiply. Add. Multiply. Add. And then multiply one more time. And so now I get a total of 3. And guess what? If I had substituted -1 into this, I will get 3 out. And if you don't believe me, you can try it. Okay, but I promise that that's the case. All right, on your assignment, you will either be asked to use direct substitution or synthetic substitution. So today you have to follow the directions. But in the future, you can decide if you want to use synthetic substitution or direct substitution.